This is a short video on synthetic division. Synthetic division is used for the division of polynomials. We're going to start with finding the quotient and remainder when x cubed minus 4x squared minus 5 is divided by x minus 3. When you use synthetic division, we're basically using the coefficients for the terms in our polynomial. So I'm going to start with the coefficients on my x cubed minus 4x squared minus 5. And I notice that one of the powers in the descending order is missing, and that is the x to the 0 or x to the first power. So I'm going to start with writing those down. We have 1, I need a color there, 1, negative 4, I have 0 x's, and then a minus 5. And now I'm dividing it by x minus 3. When we do that, if we think about what our factors are, our zeros are, x minus 3 looks at 3 being a 0. So I'm going to use 3, not negative 3, but 3. And I'm going to do synthetic division with 3. Okay, the first step is that I bring down my first coefficient. So my first coefficient was a 1, so I bring it down and it goes here. Then I take the 1 and I multiply it by my divisor of 3. So 1 times 3 is 3. And then I combine this set of terms, the negative 4 and positive 3, I get negative 1. I multiply the negative 1 by the 3 and I get negative 3. I have 0 and a negative 3, which yields a negative 3. And a negative 3 times 3 is a negative 9. And a negative 5 and negative 9 would make a negative 14. Now what I can tell from this negative 14 remainder or last term is that this is not a 0 or a factor of my polynomial, the x minus 3. So it's going to give us a remainder. And what happened was this now went to one less degree in my polynomial. So this final polynomial is going to be x squared minus x minus 3. That's the polynomial. And then I'm going to have a remainder of negative 14. So I would have plus a negative 14 over x minus 3. And that is what the division yield is if there were a long division. What I really have, if I were to write this out as a check, would be to the divisor, which was x minus 3, times my quotient plus my remainder should equal what I started with. So my divisor, which was x minus 3, times my quotient, which was x squared minus x minus 3, plus my remainder, which was a negative 14. This should equal what I started with, which is x cubed minus 4x squared minus 5. So if I do the long division to check that, I would be going x squared times x, which is x cubed. X times negative x is negative x squared. X times negative 3 would be negative 3x. Negative 3x squared. Negative 3 times negative x is positive 3x. Negative 3 times negative 3 is positive 9. And then I'm going to add the negative 14. So I'm going to write out that whole thing again so you can see it. That was x cubed minus x squared minus 3x minus 3x squared plus 3x plus 9 minus 14. Now when I simplify that, I should get this one back. That's the question. Do I get that back? So x cubed is there. Negative x squared and negative 3x squared is negative 4x squared. The 3x's will cancel. And 9 minus 14 is negative 5. And sure enough, I get back the original. So this up here is what I get through long division. Using, actually I shouldn't say long division, synthetic division. Let's try another one. Let's do let me get a lined page here. 2x to the 5th plus 5x to the 4th minus 2x cubed plus 2x squared minus 2x plus 3. I want to show that x plus 3 is a factor. If it's going to be a factor, then that means the remainder will be 0. So that's what I'm looking for. That means the remainder must be 0. Okay, so I'm going to set up to use synthetic division. I'm going to use my coefficients, and if I look, I have a 5, 4, 3, 2, 1. No placeholders are necessary. Okay, so I'm going to go 2, 5, negative 2, 2, negative 2, 3. If this is a factor, that means negative 3 is the 0, so I'll put that there. Okay, now I'm going to start the process. First I bring down my 2. I take the 2 times the negative 3, I get negative 6. 5 and negative 6 is negative 1. Negative 1 times negative 3 is 3. Negative 2 and 3 is 1. 1 times negative 3 is negative 3. 2 and negative 3 is negative 1. Negative 1 times negative 3 is 3. Negative 2 and 3 is 1. 1 times negative 3 is negative 3. Put those together, I get 0. So my remainder is 0. So it is a factor. The new polynomial that I get after I've done the synthetic division would be 2x to the 4th, it's always 1 less degree, minus x cubed plus x squared minus x plus 1. And that is the new polynomial. What I really have, if I wanted to write it all out, is if I take this right here, I write that and I multiply it by x minus 3, or x plus 3, I'm sorry, I will get the original back. So if I take 2x to the 4th minus x cubed plus x squared minus x plus 1, and I multiply this by x plus 3, I should get 2x to the 5th plus 5x to the 4th minus 2x cubed plus 2x squared minus 2x plus 3. Now we're not going to go through that process, but that is the theory behind it. Okay, let's do one more. I'm going to take x cubed minus x squared plus 2x plus 4, and I'm going to divide it by x minus 2. Okay, so if I look at my coefficients, or my degrees, sorry, I have 3, 2, 1, 0. No placeholders are necessary. So right away I'm going to put down my coefficients. I'll have 1, negative 1, 2, 4. I need the opposite of a minus 2, so I'm going to use a plus 2. Okay, I'll bring down my first term. It's a 1. 1 times 2 is 2. Negative 1 and 2 is 1. 1 times 2 is 2. 2 and 2 is 4. 4 times 2 is 8. Looks like 12. Okay, let me double check everything. 1, negative 1, 2, 4. Used my 2. Bring down my 1. 1 times 2 is 2. 2 and negative 1 is 1. 1 times 2 is 2. 2 and 2 is 4. 4 times 2 is 8. 8 and 4 is 12. This is my remainder. Okay, so my new polynomial is x squared plus x plus 4 plus a remainder of 12. And if I put that over my divisor, it looks like this, 12 over x minus 2. Okay, That is the process of synthetic division. Now, this video was not meant to teach you why these things occur, what the roots are. It's just showing you a process of how you do synthetic division.